Hey, hello there. Welcome back to the CS School channel where we discuss and deep dive into the world of software engineering. Today we have a really exciting topic to discuss. It's reliability, scalability, and maintainability. Okay. Have you ever wondered how the software systems are built and maintained under heavy usage? How to scale the system when there is increase in the demand of software, and how to build the software such that the changes can be easily accommodated into the existing software. So these are the three things that we will explore today. It's reliability, scalability, and maintainability. Now, before learning any topic, you should first ask yourself why I need to learn this topic. Okay, so let's talk about it in this section. So understanding this reliability will help you to build a robust and complete software. Okay, so what does that mean? Basically, every software needs to perform its intended function, right? There is a certain function for that we build the particular software. So users expect that software to complete that function, and reliability kind of takes care of that. So reliability means building software that just works. Okay, not meeting the needs of reliability really leaves a bad impression on the user and they may not use your product. Okay, so we need to care about reliability a lot. Now, scalability. Every software system grows. Okay, so let's consider like certain software has 10,000 users at this point of time. Certainly there will be a point where that same software has like 1 lakh or 10 lakh users, right? So understanding scalability allows you to scale that software system from that 10,000 users to 1 lakh or 10 lakh users. Okay, so scalability allows you to do that, and it's really important that every engineer understands this as well. Now, maintainability. Basically, every software changes, the requirement changes, the feature changes, there can be any external thing which is causing change in our software. So maintainability allows you to change the software without making a lot of efforts. Okay, so understanding maintainability will give you enough power to change the software systems without putting a lot of effort. So that's why maintainability is important. Now let's understand reliability. So what does we mean when we say a system is reliable? So the system is reliable if it is continue to work correctly, performing the correct function at a desired level of performance, even in case of hardware or software faults or human errors. Okay, so there are two things in reliability: correct function and desired level of performance. Now consider the example of Netflix. Like whenever you go to the Netflix, you expect the Netflix to be available at all times, right? Basically you should be able to watch shows, browse shows, right? So these are the kind of functionality that Netflix provide, and you expect the functionality to just work. Okay, also you expect the performance of the Netflix to be good. Like you don't expect a lot of lag in Netflix, like it's just loading and loading and loading. Also the shows should stream at a constant pace. There shouldn't be any like glitches in the shows or like there is frame drops. This kind of things you don't expect from Netflix. Similarly, let's take an example of your banks. Okay, so let's say you use this ICICI Bank or Axis Bank or any other bank in the world. You expect you should be able to credit and debit amount from your bank. Also, when you debit something, you expect that the amount that is shown in your account should be a consistent value. It shouldn't like go up and down at random times, right? So these are the things that we expect in a reliable system. Now let's consider the example of Netflix. Okay, so Netflix as a service is built by like a lot of thousands of microservices which work together to bring you the functionality and different features of Netflix. Okay, so as a software engineer, your work is to make sure that whatever errors are happening in the system, you should be able to handle that error and recover from it. Okay, so in case of Netflix, let's say this is the basic architecture of Netflix. Okay, so there is this client which is making call to the server, which is this homepage service. Homepage service basically fetches all the content from the DB, basically all the shows which you see on the homepage of the Netflix. Then it calls the personalization service to kind of personalize the content for you. Okay, so maybe I as a user likes to watch more action kind of movies, so I will be recommending action movies more on my homepage rather than someone who, let's say, watches more of anime kind of stuff, right? So this is the work of personalization service, personalizing the content for a particular user. Okay, so let's say homepage service call that personalization service with the content, and the personalization service personalizes the content and send it to the homepage service. Now the homepage service will send that data to the client. Okay, now let's say if the system is poorly built, what will happen in case the personalization service goes down? Well, in that case, the homepage service will fetch the data from the content DB, but it will not able to personalize the data from the personalization service, right? So in this case, the homepage service will also fail and client won't be able to see any kind of data, right? But instead of that, what should happen? Even if the personalization service fails, your homepage service should work. It should send the data to the client, but it may not be personalized for the user, right? So I will get all the anime plus action movies on my homepage, and the other person will also get same data on his homepage, right? It won't be personalized, but at least we will be able to show the data to the user. Also, user should be able to watch and stream shows. So your system works, but it is not personalizing the data, right? So basically Netflix has recovered from this error of the personalization service. Okay, so that's what we need to do as an engineer. Now let's compare two pieces of code. On the left hand side, you will see a bad error handling, or the system from in which if the personalization service fails, we won't be able to recover from it. On the other hand, we will see a code base where even if the personalization service fails, we will be able to recover from it. Okay, and also this code is written in JavaScript, so a basic knowledge of JavaScript is expected. If you don't have it, don't worry, I will explain the code. Okay, so here is the function which will return us the homepage data. Now it calls this get data from DB function. Basically it will get all the content from the DB. After that, it will call this get personalized data with the data which we have received from the DB. Okay, and we will get the personalized data, and at the end we are returning the personalized data. Okay, so can you spot the issue here? Just think for a moment and spot the issue here. Okay, so the issue is that when we call get personalized data function, it might work or it might fail, because in case our personalization service is down, this will certainly fail and this will throw an error, right? And when that error is thrown, this entire function will throw an error, and as we are not handling error anywhere, this entire function will throw the error, right? So we don't get any data from get homepage data function. Okay, now in the second example, we have done a smart thing here. We have encapsulated this call get personalized data into a try and catch block. Okay, so even if this get personalized data service fails, we are going and logging the error, and we are returning this unpersonalized data, okay, which is initialized with data initially. Okay, so in that way we are always returning data from the homepage service even if the personalization service fails, and we are showing at least unpersonalized data to the user. Okay, so here we are kind of going from unreliable system to a little bit reliable system. Okay, so hope we are clear with this example. Also, we can actually avoid the personalization service itself to go down by, let's say, deploying it in a cluster. Currently our personalization service is deployed in single EC2 machine. We can deploy it in a cluster, and any EC2 machine from that cluster can serve our request. Also, we can deploy this service in multiple AWS regions, so that even if a region goes down, this service will still be up. Okay, so these are some of the examples by which we can avoid this personalization service to go down by itself. Okay, so hope you are clear with this example. Now, to recover from the failures, we should first understand what are the different types of failures that can occur in your system. Okay, so the first type of failure are the hardware failures. It includes things like your machine going down, your hard disk failing, your entire AWS region going out, this kind of stuffs. Okay, so to reduce hardware failures, what we can do, we can add redundancy. Okay, so rather than deploying your things on a particular machine, we can deploy it on multiple machines, and it's the responsibility of your load balancer to allocate the load on each of the machine. Okay, also to handle the AWS region going down, we can make sure that our service is deployed in multiple regions, right? So in this case, even if the region goes down, your other region can serve the request and serve the traffic. Okay, the second type of failures that commonly occur are software failures. Okay, basically this includes things like bad handling of error or corner cases, or maybe there is issue with your configuration due to which the entire software went down. Okay, also in case your service slows down due to increase in load on your system, right? This kind of issues comes under software failures. Now there are different ways by which we can handle the software failures, and actually there are books written on it. Okay, so we will be discussing this in the future, but for now remember this thing. Also there is this human error. Basically someone does something silly, or someone uses the software in a way which he or she should not use it, right? This kind of errors are called as human errors. Okay, so these are the different types of failures. Now as a software engineer, you should predict this kind of errors and make sure your system should be able to recover from this kind of failures. Okay, and actually we are not able to recover from the failures 100% of the times, right? So suppose there is an black hole coming towards Earth in future, right? We cannot recover from this kind of issues. Our systems will go down. So but we should be reasonably handling the errors which are easy to handle. We should be able to handle them, right? So that's what we expect from engineers building the reliable system. So this is all I wanted to cover about reliability. Let's move towards scalability. Now let's look at scalability. So even if our software system is working today, there is no guarantee that it will work after 1 or 2 years. The reason can be there is increase in your users count, there is increase of load on your system, or your system is handling much more data than it was expected. Okay, so these kind of things can affect the performance of your application, and that's where scalability helps us. Scalability is the ability of software systems to handle increased workloads and growing demands without sacrificing performance. Okay, so now let's look at a simple example of Twitter. Now let's look at Twitter and understand like how scalability affects a particular application and how we need to make an architectural changes to handle the scale which is coming onto your systems. Okay, so let's consider this example of Twitter. Twitter has basically two main operations. We will look at two features of Twitter which are very essential. The first is writing tweets, right? So users should be able to write the tweets for their followers and general public, right? Then we have like view timelines or view homepage of Twitter, right? So each user has a timeline which he or she can scroll through, read all the tweets which are posted by the people, right? So on an average, Twitter gets around 6,000 requests per second for posting. Okay, so writing a tweet, and it gets around 3 lakh requests per second for reading the timeline. Okay, so understand its difference: 6,000 requests for writing and 3,000 requests for reading. Okay, now before that scale was there, Twitter used a architecture which is shown on the left hand side, and the new architecture is shown on this right hand side. Okay, so let's look at the old architecture. So in the old architecture, user used to write tweets which used to go to the Twitter backend, and Twitter backend used to store that data into the central DB. Okay, and similarly, whenever someone wants to view the timeline, that request will be sent to the Twitter backend will send it to the DB, read all the data which is there. So it will basically scan through all the like following list of that particular user. It will fetch the tweets which are done by that following list and it will send it to the user. Okay, so this was the old architecture. The issue with this architecture is that as reads are more, there is like lot of load on the DB, right? Lot of requests are going to the DB, and simultaneously writes are also going to the DB. So it is creating lot of pressure on the DB, right? So Twitter moved to the new architecture in which, so whenever user writes the tweet, we will store that tweet in the DB, as well as we will create cache each of the users timelines which is present on the Twitter. Okay, and whenever someone writes the tweet, we will write that tweet in all of the users timelines cache. Okay, And when the user actually comes on Twitter, opens Twitter, he will fetch the timeline from this cache only rather than directly hitting the DB. Okay, so the performance where we are gaining in this approach is that we are not going to the DB again and again to fetch the timeline. Okay, so we are directly fetching it from the cache which is created by the Twitter backend, right? Only writes are going to the DB, reads are not going to the DB. Okay, so this is what Twitter has done to handle the scale, and every application actually needs to change according to a particular scale. Okay, so hope you are clear with this example. So the example of Twitter shows us that how much it is important for us to measure the load on the system and scale according to our load. Okay, now how do we measure the load on the system? So that's the question that we will answer here. Okay, so load is measured by different parameters, and it varies from organization to organization, but there are two major parameters that we use to measure load. So suppose you have a job or a batch processing system which basically processes data after some interval. Then you can measure the load on that system using throughput. Okay, now what's the throughput? Throughput is basically how much data is processed by that system in given time. Okay, so let's say you have a job which runs for 10 seconds. Okay, so it does all the computation in 10 seconds, and during that 10 seconds it like loads, processes 10 GB of data. Okay, so in this case the throughput will be 1 GB per second because you are processing 10 GB in 10 seconds, right? And then we have another metric which we can use in web applications. It is called as response time. Okay, so response time is nothing but when the client sends the request, how much time it takes for server to return the response. Okay, so whenever user will press some button like login or sign up, so how much time it will take for the server to complete the request and return the response to the client is called as response time. Okay, so these are the two metrics which are used across the industry, so just remember this. Now every system is designed to handle certain amount of load. Okay, and as a software engineer, it's your responsibility to assess how much of the load our system can handle and what we need to change in case the load is increased. Okay, so whenever you are designing the system, consider what will be the load on your system in next 3 to 5 years and design your systems accordingly. Okay, and whenever there is a time when we have reached the threshold of our load, we need to change the architecture of our system. There is no way to avoid that. Okay, so hope you are clear with this scalability. Now let's move on to maintainability. Now let's look at maintainability. So every software system has a tendency to change. The features which exist today may or may not exist tomorrow. There may be a new requirement that has come which you need to implement. So maintainability refers to the ease with which software can be modified, updated and repaired over time. Maintainability actually has three important parts. The first one is operability. It means we need to make sure that it is easy for the operations team to keep our system running smoothly. Okay, so in every organization there is a separate operations team that handles your software. It is the responsibility of operations teams to debug and fix the issues which are occurring for the users. So we need to make sure that it is easy for them to debug as well as fix the issue. Also, they make configuration changes and deploy your application with the configuration changes. So we need to make sure that team should be able to do that as well. Then the next part of maintainability is simplicity. So we need to make sure that any new software engineer that is coming into our team should be able to understand the software and it should be able to contribute to that software. We can do that by making sure that our software is well documented, all the features and functionalities are well documented, and he or she can dive into the code base and understand it well. Okay, then the third part of maintainability is evolvability. Basically every software system has a tendency to change, right? So we need to make sure that we can make the changes in the software as easily as possible. We can do that by writing the test cases, right? So whenever you write the test cases, whenever you add the functionality, you can run all the test cases and make sure all the previous functionality just works, right? So these are the three main parts of maintainability, and as engineers we need to make sure that we do great on all these three parts. So this is all I wanted to cover in this video. So hope you understood about reliability, scalability and maintainability. It is very important if you want to become a good software engineer that you focus on these three important parts. So this is all I want to cover in this video. If you have any doubt, do ask me in the comment section. I'll be more than happy to help you. Do like and subscribe to our channel to see more kind of such content. It helps us to stay motivated and make more such videos. Thanks for watching.